Hey everyone, and welcome. Today, we are going to dive headfirst into the absolutely amazing world of matter. We'll be exploring the science behind how things mix, dissolve, and, why some things float while others sink. It's a journey that really starts with a very simple question. Seriously, have you ever stopped to think about that? You've seen it a million times, an ice cube bobbing on top of your soda. But the answer to that simple question? Well, it unlocks some of the most fundamental principles in all of chemistry and physics. So stick with me, and I promise by the end of this, you'll know exactly why that happens. The properties of matter are happening all around us, all the time. That beautiful swirl of ink as it spreads through water, or that crucial sheet of ice covering a lake in winter. It's not magic. It's all governed by a kind of hidden set of rules about how matter works. And today, we're going to make those rules visible. Now, to navigate these hidden rules, you need a map, right? And lucky for us, we've got the perfect one to guide our little journey today. Check this out. This mind map is going to be our guide for the next few minutes. You see those four main branches? We're going to start with mixtures to see how different things combine. Then we'll look at the components of a solution to figure out what they're actually made of. After that, we'll talk about its properties. And finally, we'll tackle the big one, density. Each step is going to build right on top of the last. So, here's the game plan. First up, mixing it up. Then we'll perform a little anatomy of a solution. After that, we get to the fun part, density, and the big question of to float or sink. And to wrap it all up, we'll look at how all this science plays out in our world. Sound good? Let's get started. Okay, let's jump right into our first branch, mixtures. Because as you're about to see, not all mixtures are created equal. Not by a long shot. Okay, have a look here. On the left, that's a homogeneous mixture. You might also know it as a solution. Think of salt dissolved in water. It's totally uniform, right? Every single drop is the same. But on the right, that's a heterogeneous mixture. Think sand and water. You can clearly see the different parts, and they are definitely not mixed evenly. So the big takeaway here, it all comes down to whether the mix is uniform or not. All right, so now we know that a solution is a uniform mixture. So let's move on to our next branch, and let's break one down into its basic parts.
So every solution has two main characters in its story. You've got the solute, which is the thing that gets dissolved, like sugar in your coffee. And then you have the solvent, which is the thing that does all the dissolving work, the coffee itself. And here's a pretty cool fact you might not know. This doesn't just apply to liquids. The very air we're breathing right now is a solution. Nitrogen is the solvent, since it makes up the biggest part, and oxygen and all the other gases are the solutes. Wild, right?
Now this is where it gets really interesting. Temperature completely changes the game. If you're dissolving a solid like sugar and water, adding heat makes it dissolve faster and lets you dissolve more of it. But, and this is a big but, for gases, it's the total opposite. Heat actually forces gas out of a liquid. That's why fish prefer cold water. It's not just a preference. Cold water holds more dissolved oxygen for them to breathe. Okay, it's time to tackle our third branch, density. This is it. This is where we're finally going to get the answer to our original question about that ice cube and that grape. So what even is density? Well, the formula is actually pretty simple. Density is just mass divided by volume. But what does that mean in plain English? It's basically a measure of how much stuff you can cram into a certain amount of space. This forest analogy is just a perfect way to picture it. Imagine a patch of forest. If the trees are packed in there super tight, well, that's high density. But if you have the same number of trees, but they're spread way, way out, that's low density. Same amount of stuff, just arranged differently in the same amount of space. And here's where the magic happens. When you put an object in water, it all comes down to a simple comparison. Is the object less dense than the water? If yes, it floats. Is it denser than the water? Then it sinks. I mean, look at this glass. The pencil floats, the key sinks. It's all just a game of relative density. So, back to our big mystery. Why does ice float? Well, it's because water is kind of weird. It's special. Unlike most other things, when water freezes, its molecules actually expand and form this open crystal structure. So you have the same amount of mass taking up more volume. And what do we just learn? More volume for the same mass means lower density. So solid ice is actually less dense than liquid water, and that's why it floats. And this little anomaly is literally a lifesaver, creating an insulating layer on lakes that protects all the life underneath in the winter. All right, let's head into our final section. Let's connect all these scientific principles to the real world, from a modern science lab all the way back to ancient traditions. So,
In a lab, if you have a weirdly shaped object like a stone and you need to find its volume, you can use a super clever trick called water displacement. You just measure the water level, drop the object in, and then measure the new water level. That difference? That's the volume of your object. It's a simple but really powerful technique.
And this science isn't just stuck in modern labs. It's deeply woven into our history and our heritage. The brilliant Indian scientist Asima Chatterjee used solvents to pull compounds out of plants, which led to life-saving medicines. And really, it's the same exact principle that ancient practices like Ayurveda have been using for centuries. Or look at the tradition in Manipur of boiling salty brine to create salt cakes. That's a perfect real-world example of separating a solute from its solvent. Wow, we have covered a lot of ground, from mixtures all the way to density. So to wrap everything up, I want to leave you with one last little puzzle to solve using everything you've just learned. So take a look at this. A whole orange with the peel on, it floats. But if you take that peel off, the orange sinks straight to the bottom. Why on earth does that happen? Think about the peel. What is it adding? What might it be trapping inside? The answer is hiding in the principles of density we've just explored. I'll let you ponder that one. Thanks so much for joining me today.